Okay, so we're back, and this time we have an interesting problem. We've got a person that weighs 66% of their normal weight in an elevator. So effectively they weigh less in the elevator. What is the acceleration of the elevator, and which direction is the elevator going, up or down? First of all, we have to draw a free body diagram. Let's draw the elevator, and let's draw the scale that the person is standing on, and here's the person in the elevator. Now, let's also draw the forces on the person. What's touching the person plus gravity? Well, the only thing touching the person is the bottom of the elevator, which is the normal force. And then we've also got gravity acting downwards on the person. So before we continue, we can actually continue right away into summation of the forces is equal to F net. I just want to pause for a moment and make a point of that this question is saying that the person weighs 66% of their normal weight. Now what they're saying therefore is that their apparent weight is equal to, the parent weight is equal to 66% of their normal weight. Question, what is their normal weight? Then we'd be able to multiply that by 0.66 to get their apparent weight. Well, let's move this over a little bit. Their normal weight would be if they were standing on the ground, and in that case you have your normal force and you have gravity acting down, and in this case those two, because the acceleration for their normal weight would be 0, in that case Fn would have to be equal and opposite to mg to give you 0 net force and therefore 0 acceleration. So in this case Fn equals mg. That is their normal weight, mg. What is their apparent weight? Well, if you remember, apparent weight is simply what the scale reads. That's what the apparent weight is. And the scale reads the normal force. So in this elevator, the normal force is equal to 0.66 of their normal weight. You see, because mg is their normal weight, and 66% of that, you just multiply by 0.66, and that is their apparent weight. And apparent weight is Fn. So let's now continue with this equation here. Let's continue with it over here. Let's say, all right, summation of the forces equals F net. And we say, all right, up is positive, and we say therefore Fn minus mg is equal to ma. And if we then work this out, we'll say that Fn is equal to ma plus mg, and we can factor out the m, and we get a plus g. Now that we know what Fn is from the free body diagram, we also know from the question that Fn is equal to 66% of their normal weight. So we can actually set these two equations equal to one another. We can set this equal to this, and so therefore we get 0.66 mg. Basically we're saying Fn equals Fn ma plus g, and lo and behold, thankfully, yay, the masses cancel out. Thank goodness, because we weren't given the mass. However, we are trying to figure out what the acceleration is from this question. It says, what is the acceleration? That's what we're looking for. So if we come back down to the equation, how are we going to solve for a? Well, m's are gone, so we can now subtract g from both sides, and so we get 0.66 g minus g equals a. And if we factor out the g, you get 0.66 minus 1 times g equals a. And in fact, when you work that out, you get 0.34. And by the way, that's negative g equals a. And that works out to be 0.34, enter 9.8 times, and the answer of negative 3.33 meters per second squared. So, now that we've figured out the acceleration, yes, is negative 3.33 meters per second squared, then the question now is, the second part of the question is, which direction is the elevator going? Is it going up or is it going down? Well, unfortunately, most students would actually not be able to answer this 100% correctly, because most students would say that the elevator is going down. And of course, they would be right. But if students said that the elevator was going up, they could also be right. And why this confuses people is because acceleration does not provide direction. In other words, acceleration does have direction, but it doesn't tell you which direction something is moving. The only thing that tells you which direction something is moving is the velocity. Now, is it possible that the velocity could be up, but the acceleration is down? Yes, the acceleration could be up. Sorry, let me say that again. The velocity could be going up, but the acceleration could be down. Is it possible that the velocity could be down and the acceleration also down? Yes, that's also possible. Think about the situation when you yourself, most people have had life experience in an elevator. When you get in at the lobby and you push the button for the penthouse, then you're going to be accelerating up, which is a positive acceleration. But when you get near the penthouse, so here's the building, you start to get near the top floor, the elevator starts to slow down. But it's still going up, but it's slowing down going up. And that is a negative or downwards acceleration. On the other hand, if you get back in the elevator at the top floor and hit lobby, well then the acceleration is the elevator is going to accelerate down, and your velocity is going to be down also. So both of these situations are possible. It's a bit of a trick question. Hope you enjoyed that problem. We'll see you next time.